Hi everyone, welcome to all of you in my subsequent lecture of variable volume reaction system. So in the previous lecture already I've discussed about the effect of number of moles on rate of reaction, right? So today I'm going to discuss about effect of pressure and temperature on the variable volume reaction system. Effect of pressure and temperature on VBRS system, right? So the thing is that so yesterday, what I talked that I have defined a parameter that was called as epsilon that is equals to ya naught multiplied with delta, and if you can call it delta A if A is your reacting limiting reagent, right? And even if also I have derived that NT equals to NT naught plus NA naught delta A action, right? But since we are talking about that, if let's say the reaction is occurring in the gaseous phase, right? So I am assuming that ideal gas behavior, right? So we know from ideal gas law that we can write P naught V naught equals to NT naught RT naught. If I'll assume this one is equation first, and we know P into V equals to NT RT, right? So this one is equation second. So if I divide equation first and second, so we will be getting that P naught V naught divided by PV that is equals to NT naught RT naught divided by NT also. So this R and R will get cancelled out. So finally you will be getting that P naught V naught divided by PV that is equals to NT naught multiplied with T naught divided by NT multiplied with T, where T is the temperature and all. So here I am assuming that pressure, we are very much interested in calculating the number of, volume of the reaction because we are interested in knowing the effect of pressure and temperature on the volume. So we can write V that is equals to NT divided by NT naught multiplied with P naught divided by P and multiplied with T by T naught. Is it clear? And previously I have talked about NT equals to NT naught into 1 minus epsilon A xn. I can write V is equals to NT naught into 1 minus epsilon A xn divided by your NT naught multiplied with that P naught divided by P into T divided by T naught. Fine. So the thing is that this NT naught and NT naught will get cancelled out. So you will be getting V is equals to, sorry, there will be a V naught also. We will be getting V is equals to V naught into 1 minus, sorry, this is 1 plus epsilon x, 1 plus your epsilon ax into your P naught upon P and T by T naught. So now, so we have got a formula that V is equals to V naught into 1 plus epsilon ax. Again, you will be getting P naught divided by P and you will be getting T naught by T by T naught. So now, what output that you can get from this formula? So the thing is that if you will increase the pressure, your volume will decrease. Obviously, it should happen. And if you will increase the temperature, what will happen? Your volume will increase. Obviously, it's also valid in case of ideal gas. So the thing is that In case of ideal gas, if you are assuming that your gaseous mixture is your ideal gas, so in that condition, you can understand that if you will increase the volume, if you will increase the temperature, this kind of effect will happen over here, right? So this was the effect of this was the effect of pressure and temperature on the variable volume reaction system. But now I am going to discuss about how you can write the rate of reaction when the variable volume system will be there, right? So I'll talk about that. So first, if we talk about constant volume reaction system, what we can write that minus of Ra, that is equals to minus 1 upon V, and that is dNA by dt. Means I'm writing these things for the constant volume reaction system, and again I'll after that I'll come to the variable volume reaction system. But before going to understand the variable volume, we need to understand the constant volume. So finally, I can write minus d upon dt of your Na by V, where V is constant right now here in this case, right? V is not going to change over here. So directly we can write that minus of Ra, that is equals to your dCA upon dt minus dCA by dt, that is equals to minus d by dt of Ca naught into 1 minus Xa. So that is equals to Ca naught dxa by dt. In terms of conversion also you can write. So, but when we talk about that variable volume reaction system, so what I can write that minus of Ra minus 1 upon V dNA by dt. Here volume is not constant. So you cannot take this inside the differential. So you have to do some different tricks. But I'm assuming temperature and pressure is constant. You know these things. And now you can incorporate this temperature and pressure terms in your reaction system also. This is not a big deal now for you. So that minus of Ra, that is equals to minus 1 upon, you can write V is equals to V naught, 1 plus epsilon AXA. And you can write now d upon dt of Na naught 1 minus Xa. Is it clear? But now the thing is that this Xa is a variable term. So, and already Xa will vary with respect to time because in a reaction conversion changes with respect to time. So now I'll take this Xa inside the differential. So I can write minus of Ra, and that is equals to d upon dt of Na naught into 1 minus Xa divided by V naught into 1 plus Ex. Is it clear? So you can write now your Na naught by V naught, that is equals to Ca naught. So you can write that minus of Ra, that is equals to your Ca naught and d by dt of 1 minus Xa divided by 1 plus epsilon A x. Right? So this is the case over here, that this is valid for variable volume reaction system. Or it's better to write these things over here. Better to write here that this one is your V naught, and after that you just keep this outside of the differential because your V naught is constant, right? So let's try to do one more thing. Because V naught is constant, that can go inside the differential, right? So that's what. Again, I'll rub this and we'll write. Yeah, so you can write 1 plus epsilon AX and d upon dt of that. You can put and a naught by v naught over here and 1 minus x. Is it clear? So now you can write minus of RA that is equals to 1 upon 1 plus epsilon A x A, and this one will be your CA naught, and you can write your dxa. This will be minus dxa divided by dt. So this will be your rate of reaction in terms of variable volume reaction system, and we know that V is equals to V naught into 1 plus epsilon AX. So from here, if you want to calculate the value of XA, you will be getting 1 upon epsilon V upon V naught minus 1. So now you can substitute the value of XA over there in the expression, and you will be getting that minus of RA that is equals to CA naught upon 1 plus epsilon AX upon 1 upon V naught epsilon, and you will be getting dV upon dt. So finally, you will be getting minus of RA that is equals to CA naught divided by V naught into epsilon, right? And V naught into epsilon and dV upon 1 plus epsilon A. You can write now d ln V divided by dt directly. Probably. So just I'm not doing anything uh, extra. Just I am doing some kind of mathematical arrangement, and then again I am getting some kind of different expression in terms of conversion, in terms of volume. So you can write the rate of reaction in terms of conversion as well as in terms of volume. Also, that depends upon the question, that how which kind of information that has been given in the problem and which kind of information you want to use. So it will become very easy if you know the conversion and if you can shift from one variables to the another variables, right? So that is important. Otherwise, if some twisted question will come in the examination, then you will be thinking, okay, I don't know how can I convert these things into this. But you should know the idea that how can we convert the volume into concentration into conversion into the volume, and we can write the rate of reaction in such a way. Okay. Okay. Thank you all for attending the lecture. And I request you, if I would request you that please share and subscribe the channel, as because I am making this video from my with my full potential. So, and also share with your friends. Okay. Thank you.